For number 8, we're asked to calculate the velocity of a star given the wavelength measured from that star. So this is the wavelength from the star. However, we're also given the wavelength of a hydrogen spectral line that will occur in a laboratory. So what we're looking at is Doppler shift. What we would have measured in a stationary source in a laboratory is one number, and what we're observing from the star is a different number, which indicates that the star is moving, or that we're seeing a Doppler shift. So to do that, we're going to need the velocity equation, and the velocity equation is v equals Doppler shift, or the change in wavelength, divided by the wavelength observed from the star times the speed of light. So to answer this question, we first need to be able to calculate the Doppler shift. So from our first equations on the first page, the equation for Doppler shift, or the change in wavelength, is delta lambda, or the Doppler shift, equals the wavelength observed from the star minus the lambda nu, or in other words, the wavelength from a stationary source. So this one is going to be our lambda nu, and this one is going to be our lambda from the wavelength from the star. It's important that we don't get those two mixed up because we want to make sure we're subtracting the right thing from the other. So Doppler shift equals 656.445 minus 656.285 nanometers, giving us, that's just simple subtraction. So when we put that in our calculators, we get 0.16 nanometers. So we can take our equation for velocity, plug in our Doppler shift, which is 0.16, divide that by the wavelength from the star, which is 656.445 nanometers, and multiply that by the speed of light, which is 3 times 10 to the 8th meters. Nanometers and nanometers would cancel out. So I have calculated 0.016 for my Doppler shift. So to calculate velocity, I'm going to take 0.16 and divide that by 656.445, and I'll get that giant number. And I want to take that and multiply it by the speed of light. So I'm going to hit the times button, and then again, just to be safe with my order of operations, I'm going to do a parentheses, and the speed of light is 3 times 10 to the 8th, so I'm going to hit the EE button and get 8. And then I will close my parentheses and hit equals, and I get that number, giving us a velocity equaling 73,121, etc., meters per second. Now that's really long, so I'm going to estimate that as 73,000 meters per second. Now what I know about this is that this is moving away. This star is moving away from Earth, and I know that for a couple of reasons. Number one, the delta shift is a positive number. So that tells me two things. Positive numbers means away, but another way of looking at it is if we simply look and we see that the wavelength was supposed to be 656.285, and when we measured it from the star, the number we got was longer. And so a longer wavelength indicates that the object emitting the wavelength is moving away. Because this is a red shift, each successive wavelength is emitted from slightly further away, making the wavelength appear longer.